Now let's turn our attention to the present value of an annuity. And I've already drawn up on the slide here our representation, our timeline for an annuity. Notice that we're receiving an annuity amount A every period. In this case, for 4 periods. We get it at the end of the first period, we get it at the end of the second, the end of the third, and the end of the fourth. So the end of each period is designated by the number along the bottom, which would be, we could think of as n in most of the equations that we use. If we found the future value of the annuity, okay, which was our little FV sub A that I've circled out here at the end, we know how to do that. We've seen that previously. Now, we could just find the present value of an annuity by first calculating the future value of the annuity, which we've just done, and then just discounting that by n periods, in this case by 4 periods. That would bring the value back here to a present value amount, which would be the present value of an annuity. So the present value of an annuity is equal to this future value of the annuity over 1 plus I to the n. So we could do that, and there's nothing wrong with that. Having said that, sometimes it's easier just to do this more directly, rather than going through the future value method first and then finding the present value. Just find the present value directly. And with that in mind, we can calculate the present value of an annuity by just calculating the present values of every one of those annuity payments, A, just find the present value of each of the 4, and then add up all those present values. In Table 9.4 in the text, and also in Appendix D of the text, Appendix D just gives a more full version of Table 9.4. In Appendix D of the book, there's a table for the present value of a $1 annuity for various N and I amounts, for various interest rates and numbers of periods in the annuity. Using that table, we just find the present value of an annuity by multiplying the annuity amount A. So we're finding the present value of this stream of cash flows. The cash flow amounts are A. We're multiplying it by the table amount, which is this present value interest factor for an annuity. And this comes out of the table. So this is coming straight from right there. So we're going to take the annuity amount, multiply it by this table amount, and get the present value of an annuity. Let me mention there's a formula that you can use for future value and for present value as well. Those formulas are listed in a footnote in the chapter, in 2 different footnotes in this chapter. There's nothing wrong with using that. Having said that, just for representation here, it might be easier to think in terms of using the table. So let's assume that our payments, we have a $1,000 annuity payment. It's received at the end of every period. The number of payments is 4 periods, and the discount rate is 10%. If we do that, the present value of that annuity, the present value of this $1,000 stream of cash flows, is the annuity amount times this amount from the table, present value interest factor for an annuity. In that table we look up n equals 4 and I equals 10%. We'll find 3.17. I would encourage you to go look at Appendix D and see where that 3.17 number is coming from. So 1,000 times 3.17, $3,170. So that's the present value of this annuity.